How's it going, everyone? Welcome on in. Happy Friday. We made it to the weekend. I'm really excited about this because we figured out our memory leak. I did. I'll explain it probably multiple times just in case people miss it. The idea was pretty straightforward. In fact, it's something that I already kind of knew about because I've written some of my own GPU kernels. When you're writing a GPU kernel, the inputs and outputs are fixed per kernel compilation. At least when I was doing it. So this was 2 years ago, maybe more. I was writing a GPU kernel, and in order to get the kernel to compile, you have to give it input-output dimensions. If you do not have the same dimension for, say, a different input, you have to create another kernel, and you have to compile that kernel. What I was doing in my code here, I was using a framework, libtorch. It knows this. And when I dynamically, hey, how's it going there, Karthik? Oh, Karthik, good to see you. Welcome on in. Happy Friday. Good to have you here. So the idea was when you create a dynamic size, so right here we had a window, and I was creating a window that was a dynamic size right here. So it would shrink and grow, and it would be the shrink and grow for inputs and outputs, which is a problem. And it would create a not unbounded amount of memory, but more than 100 gigabytes worth of memory needed in order for that to work. And I don't have that much money. I do not have that much memory on my computer. So it obviously looked like a memory leak. It wasn't a leak per se. It was more of me being naive and forgetting about this thing that I should now I'll remember it. Because I've got this mark right here on my computer, right here, you can see. I'll kind of highlight it real quick. Right here, the swap line. This is where the problem is, right here. And you don't ever want to see that. See how it's all like bright red? You never want to have to swap, and that's why we were seeing a whole bunch of problems. So today what we're going to do is we're going to be walking through this here, inputs and outputs. I want to train the model on the data. Now we can actually train it. I want to make the output prettier when we're printing the loss. So I want to prettify this. I want to make this prettier here. And then I want to, we need like a generator. We need to write a generator function so we can see what it looks like. We want to see what it looks like. What is it actually printing out? And what would be neat is we need to save the model. So we got a lot of things to do. All right. So we need to save load model. We need a generator function. So we can chat, basically a chat function. So we probably call it chat. I think that would be nice. That is the current plan. So that's what we got to do today. I think we can do it. And then if we achieve that, we can move on to the next project, because there we go. We made it work. How's it going there, John Madden? Good to see you. Steven, you don't need a prettier. You're already prettier in your own way. Well, thank you. John Madden, thank you. That's very nice for you to say. I appreciate it. Good to have you here. Oh, that was nice. Oh, wait, let me get the next song going here real quick. There we go. Click there. All right, there we go. Okay. So I want to so here's the deal, because I'm only getting 50% of the screen real estate for all my loss functions, because I'm getting all this MPS float, which I know it's an MPS float at this point. We're good to go. We don't need any more details than that. So this is what we're going to do. So let's get started on this. So we're going to save and load the model. We're going to create a chat function. I'm just going to call it a chat function. So this is our plan for today. Let me put this in our main file so we have a centralized to-do. I'm going to copy and paste this. All right, here we go. All right, and I want it to be pretty loss output. Then we're going to do a save load model. And then, hey, Ruchi, good to see ya. Welcome on in. Happy Friday. We made it to the weekend. Pal, check your direct messages. Oh, sure. You know what? I'll do that right now. Let me pull that off the screen so you can't see. Let me see here. All right, 1 second. Where are we at here? 1 second. Mark unread. Where is this? Here we go. Okay. Ruchi. Here we go. All right. What'd you say? Hello, pal. Currently, all right. So you're agent. You're working on some code over there. Make it pub. Oh, open sourced your tool max version. Ooh, very nice. All right. Oh, you posted a post. Is okay. So I can post. You made this public. So here we go. Open sourcing your auto heal AI. Hey, very nice. All right. Good job. Good job. All right. What's your auto heal? Hey, how's it going there? Nemo Zwitch. Oh, hi. Good to see. Wait. Hold on. Kunal? Wait. It's been a while. Is it Kunal? Tell me I forgot. Let's see. Karthik, hey, beautiful soup, Python library. There you go, Karthik. Yes, Kunal. Hey, all right, we remembered. All right. Been a minute. Hey, Stephen Mitchell. Good to see you as well. Welcome on in. Or Michael. Sorry. Michael. I got to say it the right way. How's it going there, Sot? Good to see you. Thanks for clicking the hi button. So you've been fascinated by the limitations of text-based coding AI. The fundamentals of flawed user interface automation is that the system cannot actually see the rendered DOM. So what you did was you made it be able to see it. There you go. How's it going there, LT Mods? Been a while. Good to see you. Welcome on in. Happy Friday. We made it to the weekend. How are you? I'm doing great. Thank you for asking. So you built AutoHeal, autonomous visual repair engine. Instead of just reading your code, it boots a headless browser, locally capturing the exact DOM state. Very nice. I like it. Ooh, Figma to code, macro crawling, 0 to 1. 0 to 1, there you go. So you can build it all from 0 to a finished product. Very nice. Here, I'm gonna click the heart button. Nice. I will repost it too. There you go, reposted. Boom. All right, did you make any progress? Your GPT, yes I did. We're working on that today. That's the plan right now. That's what we're gonna do. We're gonna make it happen. Let me go over here really quick and get everything back so I can bring this over here. Hey, Ruchi, fantastic work. You did a great job. Very good job. All right, let's get our code back. Yeah, so that's the plan. LT Mods, yeah, been a bit. It's been a bit. Okay. Hey, Sergio, good to see you. Welcome on in. Happy Friday. Good to have you here. Busy these days? Yep, there you go. Big thanks, man, supporting. Well, you're welcome. You did a good job. Yep, exactly. Exactly, Kunal. Understood. Much time to work on your website projects. Been running all over Finland. Hey, all right. Hey, Quick Fix. Good to see you. Welcome on in. We might get a Minecraft server going here pretty soon. That sounds like it'd be fun. How's your AI company going? Seeing any MMR. Do you mean MRR? I think is what you mean, Michael, right? MRR? Monthly recurring revenue. Yes is the answer. You got it. Almost done. Sounds good, quick. Sounds good, quick fix. Okay, so we're gonna save load model and we're gonna add a function, a pub function chat. We're gonna add a chat function. Here we go. Here we go. Excellent. Okay, so we got some work ahead of us here. And if we do this right and we don't make any more mistakes like we had yesterday with our memory leak, then we will be able to complete this project today. Hey, Venom, good to see you. Welcome on in. Happy Friday. Good to have you here. Kunal, now I completed DOM and started events. Excellent. All right, good to hear. Now I have to start promises. Ooh, promises. Yep, all right. I like those promises. Async programming, you guys. You're starting something somewhat like Python. Yeah, you know, I'm starting to somewhat like Python. Clanker Plays. It's so good, right? I love Python too. It's one of my favorites. Okay, so let's do this. All right, so let's do pretty loss output first. We can do that here, right? So here's our loss. We need to convert this to a float, right? How do we convert a tensor to a float? Let's see. Google, TCH, Rust, tensor, float. I64. Let's do I64. How do we do that? And how do we do that? All right, let's check this real quick. All right. Can you pin my post link here with your permission? You agree? Where's the post link at? What's the tallest building in Gaza? Oh, trick question. There are no buildings. Ah, hey, Louis, I see what you're doing there. That's terrible. That was terrible. Let's see. You have promised you're to. All right. Sounds good. Sounds good, Kunal. Sounds good. What is the part 10? Oh, geez. Yeah, you've been catching up, Michael. Yeah. So we have written completely from scratch our own transformer in Rust, and it works. It was working. It was working. So now all we have to do is get it to train more on our data. I gave it my text data. So you see how we've got this, a whole bunch of, chats right here. A whole bunch of subtitles, right? Subtitles. So yeah, link is in your DM. All right. Got it. Let me see here. So Ruchi, what are you talking about? Let's see. So we got the link, right? The link is right here. Where did we put it? Right here, right? Here you go. All right, Mr. Void, see, can connect and send me indeed. Okay, Ruchi, why not post it here? There you go, post it. Yeah, exactly, Mr. Void, exactly. Hey, Neva, how's it going? Good to see you. Happy Friday. Made it to the weekend. Some Pydantic there, Karthik. Yep, there you go. All right, so we want to convert this into an i64 really quick. Where'd we put that at? Is that over here? Do we have to open it again? We're just open it again. Here we go. Make it easy. All right, quick little i64. All right, yes, this is what? Int 64 value. Not an int. I want a float. Float 64 value. Can we do that? All right, let's try this. All right. We'd say println exclamation point, and we're going to put in a loss.float 64 underscore value. Is that what we do? And we do an ampersand. This is just a little bit much for me, for my tastes, on what we want there. All right, is that going to work? This method, what? Wait, no. wait. There is a method called fint64 value with a similar name, but why is it an fint? I want a float, not an int. A float, not an int, guys. Is there anything you guys are stuck on? Oh, we're good. So Neva, yes, let me tell you the story. So yesterday I ran into what I thought was a memory leak. Tell me if I'm wrong. I'm pretty much solved it. But however, when you're creating kernels on the GPU, right? GPU kernels, you have to define the inputs and outputs, the size, the dimensions. And if you want a different input output, you have to create another kernel, right? And so if you have like 1,000 input output shape sizes, you need to create dedicated kernels for each of those. And all of the gradients will be stored at least in libtorch. So what I was doing was I was creating a random size on the input output for every training cycle, for every essentially batch. And it was exploding my memory on my machine. And that was the problem. Pydantic TypeScript version of Python. Is it? Oh, yes, exactly. Yeah, so typing your Python with types. Do you provide follow along code based on, yes, building? Yep, exactly, Michael. That's basically what we're doing right now. You're following along with us coding. I cannot share a link here. Ruchi, I mean, if you want, yeah, go for it. It's up to you. You're free. Go make it happen. Is your Rust GP open source? Yes, it is. All right, where are we? Git status. So I've only got a few unchanged things here, and our code base is right here. Here's our code base, right? No, not this one. This one? No. We'll find it. Let me find it real quick. I'll put it on link share. Give me a sec. Ruchi, yeah, share on link share if you want to. Definitely. Let me see. GitHub, Steven. I will grab this for you guys and put it on our link share. This is Rust Transformer. Here we go. Rust Transformer. And it's really simple. It's only 3 files. Right here. Really easy. And we wrote our own tokenizer. Look at that right there. Our very own tokenizer. Here. I'll post this on link share. There you go. Link share. Awesome. Fantastic. Hey, Tinnels. How's it going there, Tinnels? Terry A. Davis goated. Wait, Terry A. Davis. Wait, why is it? It depends on how you code the kernels. It can be someone is coding it badly. Oh, got it, Neva. Okay. Well, you know what? We got it working. We did. We got it working. So that means we can contribute. Absolutely. Feel free. If you want, go for it. It's right here. It's public. It's a public repo. Here, let me see. Let me edit this. All right, so description. This is, what do we do here? We are a transformer GPT in Rust using libtorch. That's it right there. Save that. Easy. Oh wait, but we don't have any releases or anything, so let's just uncheck those really quick. There we go. Let's clean it up, make it organized really quick right there. Yes, you contribute to Steven's stuff. I did in the past. You might even get a video over your contribution. Yeah? No, that was great. Usually what you do for kernels is choose a proper size and then have a few dead cells. Yeah, exactly. That's what I should have done. That's what I should have done. You know what? But we're good. We're good. We just have a fixed kernel size now. Let's see. Brother. Hey, how's it going there? Pap for Papa. How many years of experience do you have? All right, you guys, thank you for asking. Glad to have you here. My name is Stephen Blum, CTO at PubNub. We are an API company that provides communication, mostly for your phone, with in-app communication experiences, just like, you know, chat, right? Chat, multiplayer gaming, telemedicine, on-demand delivery. We raised 134 million. We're Series E. 1 billion devices are on my network already. 68 patent claims granted. You could see them. They're on my LinkedIn. Yes, I did. I wrote those patents. I sure did. Hey, Derek, good to see you. Welcome on in. Python GUI, Karthik. I got it. Ooh, 8. Kunal, 8. Terry, 8. Davis. Right. Okay. Temple OS, right? Holy C. Holy C. Yep. How did you get into coding? What kickstarted you? I wanted to be a game developer. Like, make you think you want to do the full time. Yeah, I wanted to be a game developer. I want to make video games. I played, you know, all the video games, and I'm like, I want to make these. And so I started being a programmer. That's how I got into it. Rust is very, very little. SAD can contribute, but if something is related to Python and JavaScript, then you can. I love those languages. Those are great languages. Right, you wrote kernel yourself? Yeah. I did it using a higher level language, sort of like Triton. It was a Triton-like language. So I didn't have to worry about certain things, but it was still basically, it wasn't C++-ish language. It was a Triton-like language. What is Series E? There's different venture rounds that you have. So it goes like, you know, Series A, B, C, D, and E. And the further you go means the further your company is and the more money you've raised, basically. So you're kind of a gamer. What about GTA 6? Yeah, did you guys pre-order it yet? Did you pre-order? Does PyTorch occupies more CPU? Karthik, yeah, I knew it. Karthik, you got it, Karthik. Got it, so you wrote it and the compiler to the thing and did a bad job at it. I mean, when I wrote it in libtorch just now, so here's our, like, never here. So when I wrote it here, right here, when I was creating my batches, this is where I did it wrong, to let you know. Right here, with our window sizes, I created various batch sizes with various windows, which means that you have to build and compile the kernel for every single one. And I was doing every single variation that I could. Whoops-a-doodles. That's where the problem was. Come on, Stephen, we have to do a C++ CUDA stream. Ooh, Derek. Okay, maybe. That's a good, here, let's put it on Discord. Ideas. Here, let's do the ideas here. Wait, no, not this one. Stream ideas. Perfect. Here we go. New idea. All right. CUDA C++ stream, and that's AI. That's right. Custom kernels. There we go. Post. There you go. All right. Kind of funny how 90% of the DL boils down to the deep learning. We can write this now in a convolutional. Let's do it. Yeah. Crank 100 GPUs on it. Oh, it works. How did that happen? I know, right? AI is very forgiving. It's kind of crazy. Hey, Squirrel Sniper, greetings from across the pond. Good to see ya. Happy Friday. We made it to the weekend, didn't we? We made it to the weekend, you guys. Good to have you here. Happy Friday. Yep. All right, let's see if I can scroll up here. It should work if you random batch sizes. I don't know, like, it does work. It just used more memory. It used more memory than I wanted it to. What I should have done is create padding, like padding values. Instead of having random input-output sizes, I needed to create padding. That would have been the trick. Just add zeros on the end, Stephen, and then ignore on the negative log likelihood loss. Just ignore it. Ignore the zeros. That's what I should have done. All right, so what does this really, is this the one thing that we needed here? So where was that at here? So it said not float, but f int 64? That's just so weird. That is so weird. Result, oh, we have to do an unwrap on that. Dot unwrap or 0, so it doesn't panic. All right, let's see if that works. Here we go, you guys. Better or worse? Better or worse? Oh, wow, worse. Wait. It's still an int. I wanted it to be a float. It's got to be a float. F int 64. Come on, really? That's crazy. Hey, life is beauty. Good to see you. Welcome on in. Happy Friday. Good to have you here. Soki. Hey, Soki's here too. Have you done state neural networks? I don't think so. Here, let's just let that run for a sec while we chat with you guys. I don't know about the state neural networks. That might be a good one though. Like the fact that the thing recompiles at all is weird as hell. I don't know. Why would you ever need that? Well, right? Exactly. You shouldn't. You should just compile once and you're good to go, right? Like Mamba. Like the Mamba, Soki. I don't think so. Not with knowing it. I might have accidentally done it. Maybe accidentally. Hey, Cardum, Mr. Blum, happy Friday. Good to see ya. You made it in. We made it to the weekend. It was like an attempt of more efficient transformers. Oh, right. Oh, Soki, I remember now. Yes, I did not do that. I have not done that. I really want to though. I think that would be a lot of fun. That's a good idea. So we should add that to our stream ideas list, right? That's what you're saying? All right, let's do it. There's stream ideas here. Okay, let's bring it up. Let's do a new post. All right. You said Mamba? Wait, Mamba. Better transformer GPT. All right. Write the better version of a making it like an improved version of transformer architecture. We could do that. I'll probably do it in Rust and AI, maybe Python. Who knows? We'll see how it goes. The compiler library you're using for kernels, but should be considered a bug in it. That's fair. I suppose that's fair. The good news is we got it working, so we don't have to worry about it now. Is there a memory leak fix? It is. Quick fix. It is. I figured it out. Oh wow, it even finished with below 3. Okay, so this loss is pretty high, but we do have a lot of data. So the loss isn't so terrible. All right, so I need this. You see here, let me rerun that really quick. Is that only going to print out the full number? See, I mean, it's interesting, but I want the float. I want the float as well. Let's also grab the float. We should say the loss. Here we go. Grab the loss. And I actually want a float value. Not an integer, I want a float. All right, give me the float, please. No, not I64. No, I want float. Float, please. Let's see here. Is the loss a sum or a mean? It is a mean. It's a mean across the batch. It's a mean. Across the batch. Yeah, so let's see. All right, no, double value. Oh, double value, okay. All right, no problem. We can do that. That one's easy. Double. Done. Oh, method not found? Wait, do we not have to unwrap it? Value F64. All right. So loss value equals F64. Let grab this over here. Paste it in, and we don't need to unwrap it apparently. All right, because it's not a conversion. It's the original value. So there we go. Easy. I like that way better. All right, perfect. Excellent. All right, let's get some music change going on here. Next song. Something more upbeat. No, more upbeat. That's good. Okay, perfect. Don't forget to use Discord. Wait, let me click on that. What is good? Quick fix. What is this? Oh, wait. Oh, stream. Yes. There you go. Quick, yeah, exactly. Quick fix is, let's see here. Music, Minecraft. Oh yeah. So I've got some Minecraft music ready right here. We'll do it in a little bit. I want a little bit more upbeat music really quick. A smidgen more upbeat music. Hey buddy, Gokul, good to see you. Welcome on in. Happy Friday. We made it to the weekend. Check your DMs, please. All right, sure. Let me see here. Cheat real quick. 1 second. All right. Direct messages. Open source auto heal. Yep. Wait. Yep. Discord link. Yeah, sounds good. Oh, pin it to the current live stream. Let me see here. Okay. Sure. We will. Just this once. We'll do it just this once, okay? Let me see if I can make that work. Here we go. All right. Boom. And then, can I pin that? There you go. There you go. Just for now. Just for now. Okay. You got it. You got it just this once. Okay. Here we go. Okay. Let's go back to our code, you guys. Let's see where we're at right now. Also, let me click this so I get in the right spot. Okay. All right, here we go. Excellent, excellent. Hey, look at, oh, it's working. This is so nice. It's so nice not to have exploding memory on your computer. It's so nice. All right. Let's see, check in search of .project. What are we checking? Oh, Squirrel Sniper. .unwrap 0 since double value returns a primitive x64. Yep, exactly. Squirrel Sniper, we figured it out. What do you recommend to implement today? I'm exhausted about the theory. I want to make something that works. I'll think about word embedding. Oh, I need to understand it intuitively. Yes, word embedding is a really good starting point. I recommend if you get it. It's also really straightforward. A word embedding is really easy. Here, let's do a quick little walkthrough on it. A walkthrough on word embedding. Okay, so step 1, you've got a bunch of words. Step 2, you convert them into IDs. So you grab all your data, all of it together, all of your data, every word, and then you create a unique set of words. So if you have the word the that appears 3 times, basically you bring it down to just one word. Then you assign IDs like 1, 2, 3, 4, 5, 6 into those words. Then those count as indices for a multi-dimensional, just a matrix, right? A 2D matrix. And numbers that look like this. And Neva taught me this. Thank you very much, Neva. IDs will assign to every row or column, it doesn't really matter, every row. And then you will get the output of that row as the word, and that counts as a token. There you go. There's a token right there. That's your token. All right there. Word embeddings, you guys. Big thanks for the support, man. Yeah, absolutely. How's it going there, Arsalan? Welcome on in. Happy Friday. Ooh, there you go, right? Link, share, and subscribe to the channel. Hey, there we go. Yep. Don't forget to like the stream, you guys. Oh, thank you. Quick fix. All right, you guys, let's get into it. Let's get into our adventure here. All right, so we are doing some coding. Batching, shuffling. We did that. We did all those things. We did it. We did it. We succeeded. Thank you for the hearts, you guys. Appreciate it. All right, let's go into our main here. Open up main so we can add in all the things that we've done successfully. Here we go. Close these off like that. And then we're gonna mark these as a nice green check mark because hey, we did it. We did it, you guys. We built it. We also did this. Here we go. These are things, we did this just now. We need to save and load and create a chat function is what we gotta do. So it's not the kernel compiling, but just the stuff on your own end that never dropped it. Yeah, it was. Exactly, Neva, exactly. Yep, it was me. It was me. Pebcap, you guys. Problem between keyboard and chair. Instead of inline calls, mixed fallback errors, you can define a clean conversion helper in the tensor type to create a lightweight wrapper struct. Oh, I suppose we could. Yeah, I suppose we could do that. Let's see here. How do we, it doesn't matter. I'm happy with this. Implement loss ext for tensor. I'm going to write it. We're going to do it. All right, Squirrel Sniper. Okay. Okay, let's try it. Is that going to work or is that going to cause a problem? Let me see here. All right. All right, implement There we go. Loss. There we go. All right. Function. Yep, there it goes. Okay. Good or not good? Implement loss ext4. What is loss ext? Oh, hey. I like fishy. Whoa, I like fishies. Thank you for the star. Appreciate it. That's very nice for you to do. My gratitudes to you. Happy Friday. Thank you so much. Does anyone know where I can get a GH200? I don't know, Derek. What is that? Usually get on Prime Intellect, but can't get it lately. What is GH200? What is the cosine similarity in vectors? That's just a way to create a float. It's just a way to create a float that's going to give you, I mean, obviously, the distance between two vectors, right? So you have vector A and vector B, and then you basically, you could do like a dot product. Basically, the idea is you want to get a number between 0 and 1, which tells you how similar they are, right? 0 to 1. So there's a lot of different math approaches for that. A lot of different math approaches. Thank you guys for the fun gifts. Oh, hey, I like fishies again. Oh, with the laughing disco. What are you doing over there? That's very nice. Thank you so much. Good to have you here. It's a CPU, GPU. I want to scale up your training project. Ooh, very nice. Thank you again for the laughing disco. I appreciate it. Grace CPU and Hopper GPU. Ooh, we're getting fancy. Those are expensive things. Can you sync chat for everyone? What is sync chat? I think I'm pretty up to speed on it. Let's see. Declare trait interface loss first. Declare the trait interface. All right. Oh, hey, another 10 gold coins. I like fishies. Thank you so much. What are you doing over there? Oh man, that's so nice. I appreciate it. Let's see, one second. Wait, bro, after your stream, very inspired by your work. Oh, thank you. My own large language model from scratch using PyTorch. I'm my engineering 5th semester. Hey, very good. You're on the right track. I recommend everything you're doing is on the good spot right now. You're doing it right. Why the matrix and why is a token composed of many numbers? I thought tokens were just one value. The probability of the word. Those are logits. So the probability of the next word is a logit, right? So a logit equals prob of next word, right? Or basically which token it is, what token, right? What I should be doing is typing this on the screen that you can see it here. All right, so let me zoom out a smidge here. Probability right there. Whoa, hey, another 2 stars. I appreciate what you're doing over there. Like fishy, I appreciate it. Thank you so much. Logit is the probability of the next word, right? And then your I guess your token is going to be a vector of numbers, right? Like 3.4 and a bunch of numbers, right? 0.4. And we'll do like 5.7. Well, probably not that big, right? 1.7. Around I like these, right? Usually numbers that are not too large. Not too large. That's a vector, that's a token. Because it's going to define the meaning. Because tokens can have like implicit knowledge across. It's like the word "the" in different contexts could be different things, and so you need to be able to capture that information inside of a token, right? Maybe easier, Squirrel Sniper. What'd you say over there? Whoa! Appreciate all you're doing over there. Thank you for the stars. Thank you for the sparkles. You're being very generous today. Tensor to F64. All right, here, let me see. I'll try that, Squirrel Sniper. We'll see. Hey, Beast Huntery, good to see you. Welcome on in. Happy Friday. Good to have you here. Steven, what's your opinion on cats? They are like the pixies of this world. That's what, right? You've seen like pixies and like fairies. They're all like fantasy, like, characters. That's what cats are. They're like, or you can think they're the squirrels of the world. But there's that is what squirrels are. Cats are great. Between all platforms. Or are only on YouTube. Oh wait, we're on Twitch and YouTube. So see here, bro. All right. Happy Friday, Beast Huntery. Read my message, quick fix. Let me see if I can find it real quick. Do we only have YouTube or also other platforms? Yes. Yep. So we're on Twitch and YouTube right now. Squirrel Sniper. Yeah. You have a cat currently watching your stream. Oh, hey, kitty. Hello. Good to have you here, kitty cat. Is the fishy Mr. Beast bot account? I actually don't know. I don't know. We're getting a lot of donations right now, though, which is really nice. Thank you so much, fishy. Probably visibility to predict where AI gives best output. Probability versus possibility. Yes. Yes. Those are good explanations. Thank you. Thank you, Ruchi. Can you sync chat between YouTube and Twitch? Oh, I know what you're talking about. Yeah, so there are some ways to like put on the screen. I could put on the screen like all the chats so you can see them all. So that is something that we tried before. And I just kind of, I stopped getting it set up. I could bring it back maybe later. Spoken repo. Oh, you want to use the Erdem? Yeah, the spoken repo. Whoa, I can run it on your Windows. Yes, absolutely. Absolutely. So yeah, Steven, you can implement a trait for a type, not define your own crate. Yeah, define it in your own crate, other than a few very cases, specifically standard types. All right, 1 second here. Function, tensor. Yeah, this is easier. I like that one. Right? I like this one. I know what this is right here. Let's indent that. All right. So, I mean, is it that much better? I mean, look at the line code. So let's try this. So here, compare it. Tensor. So this is what you'd normally type, right? So that would be tensor 2. Or would you say tensor this, right? I guess it's a few characters less, so slightly better. We're gonna use it because you gave it to us, Squirrel Sniper. You're like, here, you should use this. Okay, let's do it. Loss. Here we go. This will be our, we'll say loss. Let me see. What do we call that thing up there? What is this called? Tensor 264. Okay. Here we go. All right. All right, there we go. And that should do the trick, right? Good to go. Oh, wait, it didn't like that. Oh, it gotta be and tensor, right? And tensor. There it goes. Okay, let's try it. Good, happy now. All right. Also, you can see review your agent.py if you want, man. All right, we'll have to check it out later. I definitely want to get going on our, because how much time do we have? We've got 1 hour and 20 minutes. So the import won't work. Yeah, that makes sense, Neva. It makes sense. App where you can chat using PubNub and use the embedded live stream. Ooh, quick fix, yeah. All right, that's a good idea. I like that. Make a type and then import it into a trait. We could do that. Or .into. I remember the .intos. I forgot about those. Chaining the nicer sometimes. Yeah, I'm with you. Okay. So now that we made it pretty, thank you guys. Looking for index. Ninjas, just some. All right. V's. All right, thank you. V's V. Good to have you here. Happy Friday. All right, you guys. Yeah, chaining is nicer. I understand. Yeah. So you get the .into straight weight. Tensor .into. All right. So I'm very interested in. Thank you guys for the moderations. Thank you for moderating. Ooh, SQL Alchemy Karthik. Always. Yep. I knew it. Okay. So what I want to do next is, where do we want to do? We want to save and load the model. So let's do that really quick. Let's save and load the model. So that way we can train and then also, let's see here. So Google TCH save load model Rust. Okay. Let's get going here, you guys. All right. And that app should also sync with YouTube and Twitch. Yeah, I see exactly what you're talking about. Varstore vs.save. Oh, well, isn't that easy? Look at that right there. What an easy command. Oh, wait, that's way easier than the OT. We call it .ot. Oh, I guess it's called OT. All right. I don't know why we call it OT. All right. Sounds good to me. All right. So let's try this. I very much want to save the model, and we should do that in our main file, right? Your source main. Okay. So let's train. Let's do this with slightly less. Let me see here. So that's 400. Let's do let's do this. We'll do 40 and 10. So it's 400 total. 400 total batches is what this is. And we'll say vs.save. Call this model.ot. Question mark. Okay. There it goes. All right, let's try it. Let's see if we get our save. And then we also need a load. We need to load it. All right, how do we load? All right, var store model. Just as usual, my model architecture must match original. Fills in the net's tensors with saved weights. Okay. So let's try this. Okay. So we'll do it right before. Here, let me type it in manually so that way I know. vs.load model.ot question mark. Because we're using anyhow. We're using the result for anyhow right here. Makes it nice, cleaner. A little bit of a cleaner there. All right. So now that we have the, oh wait, it didn't like that. Oh, do we have to mute it? Right. VS needs to be mutable. Okay, sure, we can do that. Not a problem. Mute. M-U-T. There we go. Excellent. Okay. Now let's see if it loads. Let's double check. See if it loads. So the weights should be loaded, and the loss should continue on around 3.1. IRC, internet chat relay. Yeah, have fun. Have you used IRC? I have, I did. All right, 3.1, you guys, 3.1. Hey, look at that right there, load and save. All right. Should make a plan for that app idea. Absolutely, absolutely. I like that idea. That's a good one. All right. We're doing good. Okay. So now that we're training our model, now we can let it train in the background, and we can easily, let's see here. Oh, okay, yeah, that's fine. Okay, so while we're training it, let me see here. I can definitely see my video getting a little bit slow, but that's fine. It's not a big deal. Okay. Transformations directly at the local mobile edge layer. Ooh, Stephen, one of my 9 breakthroughs. Real-time spatial temporal coordinate inversion. Scroll Sniper, always good for the big flashy words. The breakthrough eliminates offline computational overhead by processing complex value tensors. Ooh. Hey, you're making your way. All right, so let's put this in a while loop. While true, do, sleep 1, done. Okay. Now it'll train forever, load and save the model, and it'll get better and better while we're streaming. And we can also write our own chat function. Yeah, let's do it. Let's write our own chat function, you guys. Let's do it. Okay. Excellent. This is exactly what I'm looking for. All right. Let me see here. All right, close this out. All right, so where do we want to do this at? Do we do that here? Yes, we do. All right, public function, chat, and we need some starter text, basically. Hey, thank you for the party hat, Sergio. Wow, I appreciate it. That's very nice for you to do. My gratitudes to you. You guys are wonderful today. Look at all the donations. You guys are gifting all sorts of things here. I think we set a new record. We have to have set a new record. Easily new record, you guys. That's a new record right there. I like it. All right, so what do we want in our chat function? And we want to return a like a string, or like maybe an and string. Can we do an answer? Maybe do a little answer return there, right? Something simple. Let's return, let's see, nothing to see here. Nothing to see here yet. Save, good, no errors. Expected a lifetime parameter. Well then, fine, we won't do that. We'll do something else. How about we save this? All right. Oh, Ask Guy. Hey, Ask Guy, thank you for the follow. Appreciate you over there on the purple platform. Got some Twitch going on. Thank you so much. You joined the right channel for software engineering. We're currently writing code by hand on our keyboard. You can see right here. We got our keyboard going. We're writing some code. And we see here, we need to say a .toString, no problem. We can deal with that. String for now, good, okay. Looking good. Or, I wonder, see here. I would like to be able to return an and string, though I don't think we can. I don't think that's gonna do what we want it to do. Let's see here. No, yeah, okay, lifetime. Yeah, avoid lifetimes. That's what I choose. I choose that. Thank you again, Ask Guy, for following. Good to have you here. Okay, so let's do our chat function here. So we need our input text, right? So, and stir, so this will be our input text. What do we call that? I guess we call it input. I mean, that's an easy option. We could just call it input. So the input chat, and also we need a %self. All right, so we got our self and our input. Right, looks good to me. Excellent, no errors. And then we want to have a max token response, probably. Yeah, do a little bit of max token response there in I64. So max response equal, we can't do an equal, so we just say I64. Okay, and then so we need to create a loop. We get a loop over our forward. So we get a tokenize loop. Oh, we could also, let's just do deterministic for now. We'll do like an argmax. Does that sound good? I think we should do an argmax. Ask Guy, can you have something like followers only chat instead of verified account chat? Yeah, we could. We could. I know how to do it. I'd have to set it up before starting stream, and I think I can change it live, though I don't want to mess with any of the settings. Because I've done that before, and I clicked the wrong button. And I don't want to do that again. I don't want to click the wrong button again. Hey, let's go in there. Maxim. Hey, Maxim. Happy Friday. Good to have you here. Souls of Sassy. Wait, Souls of Sassy. How's it going, Souls of Sassy? Thank you for joining. You joined. I'm glad to have you guys here. I'm just so excited right now because look, check this out. Our model is training. It's training right here. On our data. And what's our data? This is all Steven text. It's all Steven. Look, this is me. This is me talking. Set wrap. There you go. Look at that right there. This is all me talking right here. That's my voice recording from all of our videos. I love your energy, man. Hey, thank you. Good to have you here. Check out all the amazing things we wrote our own ChatGPT in Rust. It's running right now. You can see it's training on the left side of the screen. And on the right side of the screen, those are all the words that it's training on. Isn't that neat? I think that's really neat. Hey, Souls of Sassy, thank you for subscribing and joining the right channel for software engineering. This is what we're doing today. We are writing code by hand. What is it that you're building? I'm building a ChatGPT, as you can see here, and it has all the words that I spoke to you. So you see how I've got these words on the bottom of the screen right here? These are open captions, and we save those. We save those open captions. We make them available for training purposes, and there's a lot of words. So this is what we're currently building. All right, so while that's training, we're gonna make a chat function. All right, chat, here we go. So I need to figure out how we're gonna deal with that. How do we want to deal with this? This leaves plenty of overhead space for the host Android system or Android system layers to run concurrently. A complete transfer engine under 2 gigabytes to 3 gigabytes. Hey, Loons, good to see you. Welcome on in. Happy Friday. Hope you're having a good adventure over there. You're traveling, right? You're traveling? Squirrel Sniper is a C++ engineer. All right. Wrote all of your algorithms in C++. Very nice, very nice. Okay, so mine costs nothing. It costs nothing. No costs. Okay. So let me see here. All right. So we've got our training running. Now we need to do our chat. So we need to do a forward, right? So we need to tokenize, convert it into a batch. So let tokens equals our tokenize self dot tokenizer dot encode input, and that's the, I guess, just the let's call this message. to like make it a little bit more obvious. Message. So we know what we're dealing with there. Okay. Expected a vec of strings, but found an answer. So I guess we go vec explanation point like that. Better. All right. Tokens. Good. Let me see if I could print ln. I don't think we need to bother with that right now. Let me double check I did this properly here. Hey, how's it going there, Light Person 5? Welcome on in. Thanks for saying hi. Good to have you here. Souls of Sassy, I have a technical issue with your laptop. Uh-oh. That seems like a problem. Got it. Encode. So we did encode 1, but I think we encode the batch. Then we could say 2 device. We probably should, right? Here. Okay. I'm glad I remembered that. So let me grab this. All right. Okay. Tokens on the right device. Good to go. All right. Hey, let's go in there. Alone. PP Alone 07. Welcome on in. You can't run Spoken. It does not run on your OBS on your laptop. It should. It should. It's better if you run it in you have to run it in your browser. I think that's a better way. So run Spoken in your browser first. I think that's gonna be the trick. Run Spoken in your browser. Ooh, model trace. We're gonna trace our model. Check that out. Hello, Stephen. Hope you are doing good today, sir. I am. And Schumann, we're doing very good. Good to have you here. Happy Friday. Welcome on in. We're into the weekend. Stephen, have you ever found people who look like they are experiencing AI psychosis? Yes. How do you handle it? Like you say nothing, or do you try to tell them? Well, here's the deal. They're like really excited about it, and they're really passionate about it, and it makes them very happy. They are inside a cozy blanket right now, and if you try to take the blanket away, they don't want that. And they're like, no, I want my cozy warm blanket of my AI psychosis. If you try to take it away from them, they're gonna be angry. Right, they'll be angry. Don't take my cozy blanket. AI is the most amazing thing ever, and it can do all the things and replace all people's jobs. Let's see. Oh, hey, I was going there, Grand Breaker. Good to see you. Welcome on in. We are doing good. Can you please help me for that issue? Souls of Sassy. Well, I don't even know what the issue is, really. Like, you've got a technical issue on your laptop. You got to give more details. What are the symptoms? What are you running into from a problem perspective? Hey, Niner, 1985. Whoa, check it out. John Waters Halloween costume. Ever done it? I have not. Good to have you here, though. Niner, 1985. All right, so we've got our chat function here. Is this the correct place to put it? Yes, it is. Okay. So we need to run this through our model. So let me see. Let's see. Self.forward. Let me see. Let output. Response. Let's just call it response. Response equals. Well, it's not really a response. This is just like the next token, right? Let's call this output better. I think let's call it output. Output equals tokens. And we do an ampersand there, because that's there. Happy? Good to go? Okay. Print out. No, we need to get the last value. We need to slice it, get the last value, get the argmax. Right? Let token, singular, output -1. Wait. No, it's -1, I think. Maybe. Is that gonna work? I don't know. That would work in Python. Information. All right. So we need to get the last token there. We need to get the last token. Gotta do a ChatGPT there. Yep, that's a good way to do it. And Schumann, yep, you got it. You got it right there. Software requirements in the middle, man in the middle. Ooh, the observer. Ooh, okay, danger zone. Do you see the Minecraft server? I didn't. I haven't seen it yet. We'll have to check it out. HP laptop. Oh, wow, okay. Let me see here. I want to... All right, so there's a .i method, right? So we do a .i, maybe, right? Do we have a .i method? I don't know. We might need to grab something else. Index op. Do we have index op? Index op. Yes, we do. Okay. All right, so .i to get the specific location. Okay. And then I've got some notes over here. We need the last token. We need the last token. So in order to do that, let's see, .i please. There we go. I can do things. I can make this happen. Dot, comma, and then -1, dot. How about that? Good? No, don't like it. Unexpected. Range full. Does it have to be a tuple? It's got to be a tuple. Here we go. So, like that. All right, good. Excellent, excellent. Okay. Look at how good it's training. You see the values there, you guys? It's looking really good. Just get married at this point. Oh, yeah. I'm perfectly keeping Windows 10. Ooh, really? Wait, really? All right, all right. You can finally log in on the panel with the details I sent you on Discord. Oh, Loons, fantastic. Okay, okay. I'm looking forward to it. All right, so still training. We're doing good. We've not exploded memory. Our loss is reducing. We are training it. It's learning how to speak Steven. It is. It's learning Steven speak. Right? Data, Steven. Right here. Set wrap. Right here. It's learning all these words, you guys. All these words. Hello, Steven. Have you seen my reply? Which reply is that? Let's see. Your HP laptop camera is not working properly, and when I switch to video, that video is flickering continuously. But I have done all possible things. No use. It might be a hardware issue, or it could be a driver issue. So you can go to HP, download all the latest drivers for your model, and install them. Right? I think that's the way to do it. Steven speaks. Yep, exactly. You know it. Exactly. Exactly, Loons. That's me. That's me talking right there. All right. All right. So let's get onto our code base here. All right. So that's the last token. And then I need to get the probability. So let's do this. Okay. So we can use multinomial. Oh, hey. Hey, KB Power. Hey, KB Power. Thank you for following. Appreciate you. Good to have you here. You joined our channel for software engineering. We are currently building ChatGPT in Rust. We are building the chat part of ChatGPT, and we are currently training the model on my own words that you see on the screen. We're training it right now. And what we need to do is we need to create a function that can actually talk to the model. So that's the part that we're doing today. Quick fix. Oh, quick fix. Okay. Well, thank you for following over there too. Appreciate it. This model's awesome. It is. I'm pretty excited about it. You can see it's doing a really good job on learning all the things. It's got a lot of data learned. How many tokens is that? It's almost 1 million tokens, you guys. Almost 1 million tokens. On Twitch. Yeah, quick fix. Thank you. I should have recognized it because that's also your Discord username. Right? It's also your Discord username. Souls of Sassy. I hope you'll be able to fix it. I hope you're able to fix it because it sounds like it could be a driver problem or a hardware problem. If you can get your laptop, go to HP website for your laptop. Right? That's the thing you gotta do. Look for the drivers. You might just need to Google for it. Or ask ChatGPT. Say, hey, where can I get the latest drivers for your laptop? That's probably the best approach. Go to ChatGPT or Google and ask, latest drivers for my laptop. Local admin, I think you need more cores. Oh yeah, well, we got a few. Hey, don't worry, we're good. All this is training on my GPU, right? So let's look at our activity monitor. All right, check this out. This is my GPU core here. You got some GPU cores right there. Okay. So you can see the giant blue lines right here. It's because I'm consuming all of my GPU's cores. Yep, you see how it drops there for a second? Because it was doing another training cycle. So yeah, we're using it on our GPU. And so our CPU cores, they're mostly idle, right? We don't need them that much. There we go. Yum, GPU heat. Yeah, it is. Although I have a Mac here, And the Mac has integrated silicon, built-in system on a chip, all in one. The dream is real, you guys. The dream is real. It doesn't get hot. In fact, there's no fans. There are no fans, not a single one. What's this about, anyone? Van Schmierschra. We are building ChatGPT in Rust. We succeeded. We wrote all the code ourselves by hand, live on stream. Vanch. Okay, Vanch. Vanch. All right, Vanch. So you can see all this code. It started from an empty file, completely empty. We wrote it. We wrote our own tokenizer. We wrote our own transformer. GPT wrote our attention layer. We wrote it. There we go. Hey, Mark Lemon. Happy Friday. Good to see you. Welcome on in. Good to have you here. Damn, I know, right? Looking good. My boss makes things in Claude and tell me to make all the features and microservices in 1 week of proper backend and front end. Oh, wow. I don't have time to read Claude code. Also, I know, right? The output is too much. It's too much. It is. I see. That is rough, though. That is rough. I got it. Thanks, Neva. All right. Let's see. While your single core gives you the same GPU, less sync cost. Yes. Yes, exactly. Exactly. All right. Let's write our chat function, you guys. Where we are. Function chat. All right. So we have to finish doing this. So we need to do a multinomial, right? We need to do a softmax dot multinomial. So let's see. Let's Google this really quick. All right. So I want to say Google softmax multinomial TCH Rust. Let's get a quick example on that. This is something I haven't memorized. However, I only need to write it once in a while. All right. So my logits, multinomial, softmax, kind float. Okay. So I need to do this. And I think I can chain these together. So I can do a softmax dot multinomial. Multinomial. Yeah, multinomial. Okay. And then sampled index. Extract the sampled index as a i64 integer. Yes, I want to convert it to an integer, and that will give me the word. The next word. There we go. All right, this is great. Okay, look how smart it's getting. Look how smart it is. It is still very high up there on the list. It's going to take a lot of training cycles. Okay, so token. These are, how about this? This is, what do they call it over here? This is logits. Logits. I'm just going to call it logits. That's our logit. Well, this is our logits, but this is our logit. I'm just going to call it logits, though. Logits dot softmax, and we'll say -1. Kind, was it float? Yeah, float. Okay. And then we'll indent this, and we want to say dot multinomial, and it was what parameter? I was trying to remember. 1 comma true. Sure. There we go. 1 comma true. So that's going to get me my tensor, and then we could do. Is there a different way to do an i64? I don't mind this. I just want to do it differently. Okay. All right. Oh, hey, how's it going there, David Stream? David Stream! Welcome on in. Good to have you here. You follow you and watch. You've heard so much on Rust. Your brain is rusting. Hey, currently studying cybersecurity. What do you think? I think you're on a good path. Cybersecurity is really exciting. It is an adventure. It's kind of like espionage a little bit, right? You get to attack other people's systems, and you're like, "Ooh, what can I break today?" Right? That sounds like a lot of fun. Usually something around networking. Usually, though, it's also social engineering. Got some social engineering in there. All right. So let's keep going, you guys. Where are we here? I wanted to... Is this going to save? Yeah, that'll save. Okay. So what is that going to give us on our output when we do this? This is going to give us some sort of sampled index tensor. Let's see here real quick. Brain is rusting. Yeah, there you go. GPU is second processor for helping CPU. Yes. Also, helping code. You see, code for performance boost, right? Well, yeah. Oh, it's. What do you say this? It's a parallel processor for very specific operations. GPU, right? So you can do a bunch of the same identical math operations simultaneously in a GPU. A CPU has, it doesn't have that. It has basically a linear flow. You can have a multi-core CPU and then perform parallel tasks across the cores. However, each core is, I think, mostly linear. With a GPU, the architecture is different. Each core can compute in parallel, which is going to be, I mean, technically, is there just it's just an architecture that allows a lot more cores. So really how you think about it, right? The GPU is going to be a lot of micro cores that can do very specific math operations, and you can do them simultaneously, really easily. I think that's a good way to describe it. You got the rough idea? Get the rough idea of what you're talking about? Nice. That's all. Seems interesting. All right, nice. Good to hear it. Let's see. Oh, it's just an array. Yeah, it is. It's always an array, you guys. Agreed. GPT understood. All right, good to hear it. Good to hear it. Okay. So where are we now? I want to... So I've got my logits. I want to... So this is my sampled index tensor. And then we need to convert it into an integer. So I suppose... is there a better way? There is. There is a different way that we can do this. We just saw it. It was called I64 value, right? So we say let... we just let the token equals, let's see, dot I64 value ampersand, you know what? We made a function earlier for this float. Let's see here, tensor to F64. We could do this for tensor to I64. We return to I64. We do I64 here, right? Let me double check that. Let's double check that really quick. Let me hide this for a moment. Save, good, no, okay. Int, okay, we call it int. 51, here we go. Int 60, int 64. There we go, perfect. You're back, all right, welcome back. Good to have you here. Hey, Danny, is this coding? Yeah, we are coding. You got it. That's what's happening right now. Cool channel, bro. Hey, my dog's homework. Thank you. Appreciate it. Good to have you here. Super intuitive. You got it. You got it, you guys. You got it. Good to have you here. We're building ChatGPT in Rust. Bro, how do you learn coding? Well, you start off with something simple, right? I recommend typing the word Python, and you can say 1 + 1, or get 1 + 1. Oh, hey over there on Twitch. I see you're the first one to say hi today. Thank you, Quick Fix. 1 + 1, A = 1, A + 1, right? B = 2, A + B. Those are good ways to start. You can also say print hello world, right? Something like that. Prints out a little bit of hello world right there. A little bit of hello world on the screen. That's my recommendation on getting started, just learning the basics. Just type Python. There you go. Just type the Python. You'd love to learn this? It's so much fun. It is. Test Twitch API. Oh, you got a Twitch API. Success. You got it working. You got it working. All right. So where are we now? I want to continue this. All right. So we got our I64 function chat, and we're going to convert this into a token. It's going to be an I64, and we are going to wrap this here. Let me grab that. Instead of doing this, we are going to say, I suppose we do this here. There we go. So it's a little bit easier. And our function is, what was that called? Tensor to I64, like that. Okay. Success. Oh, we got a problem. Expected and tensor. We can fix that. Here we go. Ampersand. There we go. Right there. We got our word, you guys. We got our word. We did it. Now we can print it out. We can print it out. So what we should do is we need to run this in a loop. However, I want to print it right here. Print ln, print a line exclamation point. We're going to say token. This is not a decoded token though. This is just a number. This is just a number. Here we go. Okay. Let's chat. Let's chat with it. Oh, I'm so excited. Okay. So what I want to do is do fewer iterations. Let's see here. It's the crab language. Wait. Insta ID, Caro. All right. You guys are chatting over there. All right. So what I want is this file here. I want to open in my main, and I want to, instead of training 400, let's just do like really quick short bursts. And then I want to say transformer.chat. And then we're going to pass in hello. And then we're going to see what the next token is from there. Hello. Let's see. How. Let's see. R. Let's see how. And then R. See, we'll see what's going on there. Oh, it didn't. Wait. Wait, hold on. Oh, what? What's going on here? Weird. Oh, right. Okay. 1. Let's say 1 for now. Okay. So let's see what happens when we run this. Right? Here, let's open up a window, call this, you know what? I suppose what we could do, 1, 2. It's talking to us. It's talking to us, you guys. But although that is very weird that it's giving me a 1, 1. Weird. I don't know if that's correct. I don't think that's right. That seems wrong. All right, so how about they will. Let's try this. They and will. All right, let's see how it works. I don't know if that's good or not. I don't know if that's good. I don't know. 1, 2. Yeah, that can't be right. There's no way that could be right. That's very wrong. 1 and 1. It's basically just gonna... It's basically not working. Oh, no! Okay. All right. That's not what I wanted to see. 1, 2, 1. Oh, that's not good! Don't worry. We'll figure it out. We'll figure it out. So let me decode it. Let me do a decode on that. Let me see here. Transformer. So we'll open up our transformer real quick. FN chat. All right, so we need to decode this token. We got to do a decode here. Decode. It's in our... Let's see here. Close this. Our tokenizer. Decoder, right? So we got to decode. And that should work. I've never used this function before. Oh, it wants it to be a tensor. Okay. So we can just straight up pass it in as a tensor, and we'll get the next word. And is it going to give me... It's going to be every single token output. And it's going to decode it as a string. Okay, perfect. So we'll just use self.tokenizer.decode is what we need. Source, transformer, FN chat. Okay. So we don't need this anymore. This is going to be a tensor. And we just do this. There we go. And then we say let word equals to self.tokenizer.decode token. Right? And then we type in the word. There we go. Good. Error. No problems. Okay. All right. Let's see here. Let's see what it prints out. Let's see what it prints out. Oh, it panicked. Oh, that's not good. Oh, do we need to unwrap it somewhere? Where did you do that? Hold on. What's that say? All right. Called unwrap on error value, attempting to convert a tensor with a two-dimensional dimensions to a flat vector. Oh, right. Okay. So, let me see here. Real quick. Oh, Bernie Mac. Hey, how's it going, Bernie Mac? Good to see you. What is this? Can anyone explain? Yes. All right. So we are currently building ChatGPT in Rust, and we are training the model right now. We wrote all of the code. It seems to be working because the loss is reducing. However, my output is giving me the same identical words for no matter what token I give it, which is a problem, obviously. That's a problem. The one app for watching, it works. Just needs a little fine tuning. Yep. That sounds good. Quick fix. So we currently have it running basically, and we just need to get it to give us the right outputs right now. And we're trying to convert it into words really quick. So our tokens, our output logits. Let me see here. Oh, Bernie Mac, thank you for the flow state. Appreciate it. That was really nice. My gratitudes to you. Hey, thank you so much. That's great. Bernie subscribed too as well. A subscribe and a flow state. What are you doing over there? Oh, appreciate it. Thank you so much. Hey, this is the best day ever. Why is June 26th the day? Why is it, or June 27th, right? Depending on where you are. Thank you for the flow state. Appreciate it so much. We're doing it. We're actually building it. We wrote all this from scratch, from an empty file, completely empty. And we wrote it. It's there. We're there. We did it, you guys. So all we have to do now is just get it to speak to us. We got to get it to talk. FN chat. There we go. Let's make it talk. All right. I very much want to... Where is this at here? So I want to make sure that I'm getting everything I need. All right. No problem. I have an exam today. I have good karma, bro. Excellent. Thank you, Bernie Mac. You will do great. That's it. You got it. You cannot run Spoken. Oh, no. Cardum. Yeah. All right. So Spoken. All right. So I'll help you a little bit because you are a regular here on this channel. And thank you so much for chatting and working together. All right. So let me see here. So what you do is start easy. First up. Let me see here. Oh, what? Joshua Strozzi. Whoa, no way. It's the saws. Hey, what are you doing over there? You found me on YouTube. We were chatting on LinkedIn the other day. Hey, I don't know if you guys know who Joshua Strozzi is. Was a Twitch streamer from many years ago, and played video games, a lot of video games and things like that. Games that I played and stuff. So, what are you doing, Josh? That's crazy. And you just subscribed to my channel. Whoa, that's cool. Yeah. What are you doing? Hey, what's going on today? So yeah, it was a previous streamer on Twitch, you guys. Hey, welcome on in. And now you're a software engineer in Oregon, right? You're a software engineer in Oregon. Joshua Strozzi. No way, that's crazy. That's amazing. Welcome on in, yeah. So let's see here. I wasn't expecting that. All right, so we need to now. Let me think. What are we doing next? You threw me off, Josh. You threw me off. I'm like, yeah, it's a little bit of a fun adventure here, right? Being a streamer. Okay. So now I want to. Where are we at here? Maybe Josh might have just subscribed, but is not actually watching the stream. That could have also happened. I'll have to ping him on LinkedIn later. Like, yo, that's crazy. Thank you for the hearts. Appreciate it, you guys. All right. That's pretty neat. So that was exciting for me. I don't know about you guys. like when another streamer that you've known for a while follows you back. That's pretty neat. Okay, so let me see here. We've got our token. We're decoding now. And did we need to unwrap this? No, it seems that we are hitting an error for some reason. I need to figure out why though. Here. So we are panicking. Result unwrap error at line 72. Oh, on our tokenizer. So we're using decode because it's not the right dimensions. Attempting to convert a tensor with 2D to a flat vector. So what I need to print this token.print. I need to see what this is first. There, that'll give us the help that we need right there. Okay. That'll help us out right there. All right, let's see what we got now. Who follow you? So that is a 1 by 1. Okay, so I need to convert that into... That should be fine, though, because it's a 1 by 1 should be fine. I think, right? It's a 2D tensor. Oh, it was a Twitch streamer from the past. A previous Twitch streamer that did video game streaming and is a software engineer in Portland, Oregon. I think, or in Oregon somewhere in Oregon. I mean, whenever you say Oregon, everyone always says Portland. Like, oh, Portland! You're from what? No, not Portland. It's a different city. Oh, nice. Yeah, it was pretty neat. It was unexpected. All right, so it is an MPS long type, which is correct type, and it's a 1 by 1, but it needed to be different. Let's see here. Let's open up our tokenizer decode. All right. So let me see here. Tokens i64.unwrap into. Expecting a single dimensional. Got it. Okay. Which means that we need to use a .i to get the... How do we do that? We just want... How do we do this? So let's say I want my word... it needs to be different. Can we say .i tuple and can we just say view view.1? I'm gonna do this. View 1. How about this? Can we do that? Is that gonna work? All right, let's try it. Let's see if that works. Okay. See, no errors. Where are you from? Oh wait, we forgot to uncomment our code here. 1 second. Let me print the word. It didn't error that time, which means it basically is working, I bet. All right, I'm from Seattle, Washington, United States. I also used to live in Oregon many years ago. Hide that token. Is that correct? Is it a 1 by 1? Wait. It's still a 1 by 1. Well, it's still... I changed the view, right? I changed the view, so that should be fine. Okay. It's working. It's working. I don't know if you guys see it, but it's working. It's kind of working. It's working weirdly. It's giving me space characters and it's giving me quote symbols. But it counts. It's kind of working. Yeah, all right. No more crashes. So we need to do a series of forwards and we need to rebuild the tokens and concatenate the tokens, right? On the tensor, so we can do a concat on our tokens. That might do the trick, because I want it to be able to talk to us, right? Oh, maybe we don't have a long enough string of text on the input. So that might be it, because we're not training it on such small words. Let's do this. All right, you guys, we might have our answer. Hello, how are you today? Let's see, how many do we need? Is this the window? No, is the window 50? That's a pretty big window. Hope you are good and well. Let's try that. Also, we should open up our data and grab just some of the words here. So that makes it a little bit easier for our model train here. Let me see here. There we go. Excited. There we go. Let's copy these words here. All right. Copy, paste. Here we go. Okay. All right. Perfect. All right. Let's do another 88 over yesterday. Add some more words here. Copy. All right. Grab this. Here we go. Perfect. We're going to update this so that way our model sees exactly what we need. So that way we can get a better output. I think that's going to be the answer. It should not be space characters, at the very least. What music? Salsa, Mediterranean vibes. Oh yeah, it was there for a second. Yeah, that's crazy. You were born in Tacoma? No way. Bernie Mac. That's crazy. I'm very close to where you were born. Very close. Hey, Prince Danny, how's it going? All right, so I'm getting some output, but not what I'm looking for. All right. All right, it's just still spaces. It's still spaces. I don't know why. I don't know why. All right. It should be better than that. It should be better. Let's see here. All right, let's close that. All right, what if we did like 10? Let's try this. Let's try that. Hey, Ruchi. All right, big thanks for the support. Absolutely. You got it. I'm about to launch on NPM. Sounds good on Product Hunt. Excellent, excellent. Good to hear it, good to hear it. Maybe our multinomial is wrong. That could be it. I don't know if it's wrong or not. So no, this is in our source here. Source directory, transformer, multinomial. Here we go. So it's possible I've got this wrong here. Very possible. I need to think about that. Okay. Maybe. I don't know. Yeah, YouTube's algorithm is really good. It is? Oh, apparently, yeah. Put us right together. That's crazy. That's absolutely amazing. Okay. So where do we go from here, you guys? So it trains, gets the data, is happy, and then it gives me weird output, like an output that doesn't make sense. All right. Should we cheat, you guys? I want this to be the last day that we're doing the transformer, because we did all the code, we made it good, and the only problem is now that this function does not seem to be working the way it should be. We are getting a loss reduction. Please turn on the recent music on Mediterranean Vibe music. All right, let me see if I can find it. Here we go, you guys. Here we go. Are you ready? All right, so which one was it? This one? Is that it? No? How about this one? Here you go. That's it, definitely. All right. There you go. You got it. Erdem, you got it. Okay, so our chat... let's see here. Let's do a word. Does that work? Yep, okay. So maybe the view isn't good. View -1. What if we did -1 view? All right, let's try that. Thank you for the party poppers. All right, all right. I don't think so. I think the answer is this is the problem right here, because I'm getting I'm getting just a bunch of tokens that are incorrect. Token. That I don't know if that'll work. Colon question mark maybe? That might work. Okay. Let's see here. Close this window. All right. Token 11 N64. Yeah, I know, but I want the actual token. Print. Let's see. Token.print. Try that. Okay. Perfect. Maybe we're not training enough, like reduce your training loops from 40 to 4. I think we've been training for like an hour, and in PyTorch, when we were doing this in Python, we were able to get really good results even after like 20 minutes. Dimdom. Hey, how's it going there, Dimdom? Have you decided on the name? Yeah, well, what was it? I think we voted yesterday. We voted yesterday, right? And it was like, I actually don't remember. Do you guys remember? It was like Blumby or Blum, something like that. Something like that. We can come up. Let's see here. So let me see how really quick. Oh, holy veneers. Oh, Batman. Hey, yeah, no. Yeah. I had a lot of orthodontics work back in the day, many years ago now. I was going there. Emuba, good to see you. Welcome on in. Happy Friday. We made it to the weekend. All right. So my problem is, where is this? Are we printing the word? Yeah, we are printing the word. And it's printing like a space character, right? It's printing space character, which is not worthwhile. It's not meaningful. What if we gave it exactly 50? What if we gave it exactly 50 tokens? Like maybe that would be doing the trick. So let's see here. Are we training? Let me do this real quick. Let me open up this window here. Vertical, source, main. All right, so where's our train at here? All right, so we did 10 words. Let's see here. Let's try this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, let's do that here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, here we go. Try this one over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, that works there. Okay. See what we got here. Is it going to be more spaces? Probably. Yeah, it's still more spaces. Oh well. Try adding cargo run training logs. What's the chair, Mr. Blum? Oh, looks so cozy. It's a pretty good chair. It's an Amazon Basics chair. That's all it is. It's really cheap. It's a super cheap chair. Amazon Basics, you guys. All right. Well, at least I got a quote mark. I mean, it's a quote mark, right? A little bit of a quote mark, something. It's not good enough, though. It's not good enough. Not even close. And what is our actual value? What is our actual value? So I don't want to... It is 1... It's 1, 1, which is weird, right? Where is... All right. Well, let's do this. What are you trying to program right now? Algorithm, genuinely curious. Okay, good question. So we wrote ChatGPT from scratch. From an empty file in Rust to a complete transformer. We just finished writing the code that allows us to speak to the AI just today. However, the output we're getting is not good, right? We're getting very not good values. So in order for me to see something better, we got to do two things. One, I need to append and repeat and loop with the max number of tokens. So that's something that we should do through a range. I don't know if we could do that or not. And then basically we'll do a for loop. And then if that doesn't work, then we don't have much time left. So we'll just run it through an AI and see if it can find it for us. Because that's the only option that I can think that we could use there. Because I thought for sure that I did it all correctly. All right, let's get the next song going, you guys. 1 second. See, that is supposed to be 50. Okay, so go here. Sounds good. It's a little bit too slow. I want something faster. I want something different. All right, that sounds good. Okay. It's an AI model. Yeah, exactly. It's a real legit AI model that's not working. That's what we need to make it work. Okay. Let me see here. All right. I want to put this in a for loop. All right. So for max response size. All right. So let's do this. So we got our input tokens, we got our vector, and we could change the message because we can concatenate the message, although we already have the tokens. It would be certainly nice if we just continued to append the tokens directly. So you could probably do like a concat, right? It's a tensor. So we can concat in a specific dimension, right? So it'll give us our tokens. And we need to create a new token. Or for 0.max response. Let's see, underscore response. There we go. Let's see. We can put all this into a giant for loop and then create our output. Let's see here. To be honest, I have no idea how to code these types of programs. Oh, well, they are pretty tricky. A lot of different voices saying things and transcripts for each, trying to train the algorithm to recognize, these, but didn't know how to work unless they have a program that allows you to do that already. Oh, hey, well, you can get those for free, right? The programs, they're for free. You sure can. You can get them. It's a lot of fun, though, to learn how to write them. And that's what we're doing on this channel. We learn how to write things. Okay, so let's see. Indent our tokenizer. And then we need to have like words maybe. All right, let words equals a mutable string. Mute words equals a mutable string. And then we'll just concatenate that, right? So we'll do something naive here. So we got our word, and we say word. Oh wait, actually I'm not super familiar with that. So let's go Google. Let's see here. Yep. Let's see. Rust concat mute string. Let's see if we can do that. Like a quick little concat. A little easy. It's called push string. Dot push str. All right, so we've got a string, and we say s dot push. Okay. That's easy. It's been a while since I've done that. Let's see. Words dot push str. We say word. Done. There we go. And then I'm going to hide that. So this so far will do a good job on just giving us one response identically. So we needed to go further though. And this needs to be words. All right. Okay. String let new. Oh wait. Yeah, right. String from string from, and it's empty. So we got an empty string. Okay. We'll do an and stir here. Okay. All right. Now what we have to do is when we retokenize, we need to concat the message. All right. So let mute message string. Well, yeah, it was string equals string from message. So we can do that, right? Expected and stir found string, right? Okay, so and string there. And then we could, when we push this, we need to append this to the string as well. So let's see, message dot push string the word. Okay. And we should probably do more than that. Like we need to add a space in there. So format, explanation, word, space. We do this. Is that gonna work? Unclosed delimiter. Format and stir found stir. Okay. That, there we go. Okay. Let's see if that works, you guys. All right. We're gonna find out. I don't know. We're gonna find out. Doesn't seem to be. Oh, we're not printing anything. Okay. So let's print this. Print ln explanation for it. Words. There we go. All right. Perfect. That's it. Done. Okay. Okay. Let's see if it works, you guys. Let's see if it works. We'll find out. Is it going to be a bunch of gibberish or a whole bunch of spaces? Yeah. What is that? Okay. Come on, you guys. Really? All right. So let's do reply colon period. We'll put a period in there. All right. So it should be a few characters. We should see a few characters in there. It's just a bunch of words. And then what was our max? Oh, I set the max to very low. So let's make max bigger. Chat. Here we go. Let's say 10. 10 tokens. 10 token response. Okay. All right, let's see now. It's probably gonna be a bunch of spaces. Oh my God, look. Oh, it's way better than I thought it was. Oh, look at that. It's talking to us. Hey, look, we did it. Well, I thought we were gonna have to cheat and use the AI, but look, we did it, you guys. Check it out. Choose good to Discord applications. Hey, look, it's obviously not the log matter even. Yeah, look at me right there. Check it out. Hey, we did it. That's me talking to me. Whoa, no way. I know, right? We did it. Check it out. Oh, it's so cool. To run do blocks pretty. Yeah, pretty because look at that. We did it. And it's looking pretty good. Basically it's worked. So attention should, yeah, look at, wait, no, I mean, it's not perfect. It's not perfect by any stretch of the mean. Projections for derive, yeah, it's still talking to us though. Hey, congrats, we did it, Erdem, check it out, Kyle, we did it. Squirrel Sniper, it's alive. We did it, you guys. Hey, look at right there. Look, see all the things that you can do? Just type a little bit of code and can make it work. Oh, that's fantastic. All right, welcome, or did it hit? Now all we have to do is like let it train for a lot longer, and because it has to train on over about 1 million tokens, and we are only training it very slowly. So it's Bloxbo. Whoa, do you remember Epic Bloxbo? They're in there. You guys are in there. If I said your name, it's in there. Yep, exactly. She pulses good. Yep, there we go. We're making it. Squirrel Sniper, we're making it. I meant it to mean. Look at it. Hey, that's so cool. We did it. So, that's it. So, we did it, you guys. We did it. We built a ChatGPT in Rust. It was a lot of extra effort. We hit some bottlenecks and some problems. And it's been a while since we really wrote a full end-to-end Rust application. To be able to remember that after like maybe 2 years, because we've been doing a lot of Python and JavaScript and other things. We built it. You built it in 10 streams. Yeah, we did, Goose. It was 10 streams. Yeah, it was, because this is number 10. Number 10. You saw it. Steven, read my previous message. Okay. It's alive. It's alive. Yeah, it is. We brought it to life. Check it out, you guys. It's talking to us. It's talking right there. Oh, up, not I free, and of the math do we. It's real. Before that, okay. Let me see. You said, I found it's not about front loading for token context. It's that the middle can get forgotten, and the middle, yes, it is. The middle will get easily forgotten. It is, yeah. So the beginning and the end is what the model attends on the most, because that's where it's learning how its outputs are supposed to train. In the middle, it often forgets. So when you put your instructions, you want to give it a little bit of context, maybe a little bit in the middle, put your instructions at the beginning or the end. Instructions have to be at the beginning or the end. And then you get a good output. Wait, he means the one before that even. Oh, right. Yeah, even before that. You have revised your prompting intent examples, repeating your primary constraints at the beginning and the end. Unfortunately, that's basically it. Intent is the only real input that matters. Yeah. Got that goal, got that intent, put it at the beginning or the end. Keep it short. Keep it short, you guys. Very nice. We did it, you guys. We did it. Oh, that was such a great adventure. Okay. All right. We made it work. We made it work. Oh, I'm so curious to see what will happen if we give it a few more responses. Let's see. All right, let's give it like 20. It's going to get into gibberish because it hasn't been trained on this yet. It hasn't been trained, but we'll try. Oh, see, you guys are happy. Yeah, the batches, here we are. It's definitely words that I say. Cool things that are really tell. Oh, and I see it. I do. I see it. All right, what a great Friday, you guys. What a great Friday. We certainly did it. We achieved our objective. Comment on videos and photos and stock images can really help. They often have a lot of descriptions about the images in the description. Yeah, they're try 37, odd number. Okay, Squirrel Sniper. All right. I'm pretty sure it'll work. It won't be very good, but it will work. Odd number. There you go. Odd number. On its way. All right, it needs to go through the next iteration here, the next cycle. Here we go. Next cycle. All right. There it goes. There it goes. Oh, right there. Check it out. Let's see. Let's try to read it. Let's try to read it. 1 second. Oh, it went too fast. Here we go. Here we go. Okay. The right channel, all the right. Where we go to see the live changing. Math. We just put our tokens in there. We're all really there. It was CP. I love that. It's okay. Let's see again. We'll see how the attention, wait to see Rust. Yeah, okay. It's actually getting pretty close. All we have to do is just give it a really good overnight training. A good overnight training, and it will do way better. Cargo run, training log, CVS. Oh, right, yep. We could, yeah. That would be a good way to do it, right? Because let it run overnight. 6-7, how's it going there? ZYX, welcome on in. Happy Friday. All right, you guys, we did it. Oh, this is so great. This is great. What a great Friday. We did it. We win. We win. Thank you to me. All right. So, you guys, the plan for tomorrow. W, you got it, Kyle. W. How can we see your GitHub projects? Oh, we'll show that real quick. All right, let's do git add, git status. Model OT, L, hold on one second. The model is 19 megabytes, that's not a problem. All right, git add, git status, git commit, and I'll send you the GitHub link on Discord. I'll send it to you on Discord. We see, we got it working, exclamation point. It's good enough. We got it working good enough, let's say. All right, push to main, boom, off to the races. So we have that here in our, right here, where'd we put it? It's around here somewhere. Let's close these guys off. Don't need this anymore. Don't need that. Let's see, we've got a lot of windows we could close here. Let's close those off. What about that? Not that one, not this one. Here we go. Is it here? Nope. Oh, I do want to do candle. I want to do candle later. All right, so 1 second, you guys. Let me give you the repo. Repo, here we go. Rust transformer, here we go. Okay. This is it. Here's the answer. I will share this into our Discord. You know what? It's probably already there. I'll give it again. I'll give it again. All right. Link share. There we go. There we go. Okay. So you can see it right here. All you do is go get on Discord, click the link, and you can go under source. You can look at our tokenizer. This is the tokenizer that we wrote 100% from scratch by hand. We wrote this tokenizer. Our main file, which should be pretty straightforward. It's a really small main file. Let's do one thing before we wrap up, you guys. Let me go into our main file and mark all the things that we did successfully, yeah? Source, main, to do. All right, we got our save load function. We did it. We did our chat function. Yep, there we go. We did the training. We did batching and shuffling. Yep. And we did our tokenizer. We didn't do tick tokenizer, so I can't count that one. But yeah, you know. All right. Save. We did it all. Also, we could delete all this other debug code here. Here we go. And then you can see, here's our references, what we looked at when we were building the model itself. Let's see. Working on the app, done when you send it to GitHub. Sounds good. Quick fix. Nice. I know we did it. Okay, thanks. I'll try. All right. Yeah, it should work. It's currently, so one thing that you do got to know is that I set our device to MPS, which is a Mac Silicon. So you might need to change this to like CUDA or CPU. So if you're going to run this on your local system, you need to change this line here. You'll have to change that line right there because I don't know if you're running on Mac or not. I don't know if you're running on Mac. All right. We did it. We did it, you guys. Oh, so good. Okay, so for the plan since we've completed this series, I don't know for sure if I could say that I'm completely happy with the amount of extra effort. Though good news is when we compare Python, PyTorch with Rust and libtorch, I would say Torch, the adventure with Rust was a lot more fun because we have bacon, which is this right here at the bottom of the screen. This is our bacon right here. It was, thank you to Foodude who turned this on. Bacon will let you just write the code and basically not have to worry about running it because it's just going to compile. And if it compiles, it's probably going to work. Probably. And for the most part, it did. When we were doing this in Python, we had to do the same thing, but we had to run the application directly. So there's like no easy compilation. So that part I really liked. I liked that part a lot about the Rust development aspect of it. And it's also a little bit of bonus in there. It's going to be a little bit faster. When I looked at the overall training speed here, it's pretty good, right? You can see how fast it trains. However, I'm not super convinced that it's that much different because you're still using FFI, you're porting the data over through an interface. It's the same on Rust and Python. So the speed difference, you're still using the GPU, right? And you're still sending batches over to be trained. So in this case, hey, hope you have seen it. I love seeing that it works. Oh, I'm so happy. So would I say, is it worth it? It is mostly not that much worth it, I don't think. I don't think it's exclusively worth it because the amount of performance gain that you get does not seem to be that much better. What am I going to do in the future? myself, what I plan to do is I'll probably choose Rust first. I will probably use Rust first because I enjoyed the development experience. It was really straightforward, and it gave me a good performing model. Though, I don't know. I want to try Candle next. That's what I want to do. I want to try Candle. I think that'll be a lot of fun. That'll be a good one. Trying Candle next. Hi, Steven. Hey, how's it going? Happy Friday. You fitted, you trained, your data set supplied, and has already pre-trained. Wait, let me read that again. 1 second. Hi, Steven. Is this model fitted and trained, or is the data supplied and has already been pre-trained? It is not. This is trained from scratch. Complete zero. Look, it's talking to us. It's talking to us right there. Isn't that cool? Isn't it cool? It's talking to us. Yeah, we built it live on stream. You guys saw it. It only took us 10 streams to do it, but we did it. We made it work. You do not see the end result. Can you upload the finished project video? Well, which project? I'm working on... Wait, quick fix. What are you talking about? Need a rusty brain, then a mere Python. I know, right? So the good news is, if you're in Python right now, you don't need to use Rust to get a good performing model. You don't need to use it. I would say you can stick with Python. However, for me, being that I've been using Rust for so many years now, I enjoy it. I do. Sass Mitt, how's it going there? Explain the architecture, please. Oh, it's really straightforward. Sure. So it is a standard transformer. Here we go. All right. Wait, hold on. Let me see this. Let me close that. Okay. Here we go. Let's open up the transformer. So it's really straightforward. So I have a transformer head and transformer blocks. So that way I can stack my blocks, right? So I've got a bunch of blocks. Here we go. My embedding, standard embedding. I mean, it's a matrix, right? It's a simple 2D matrix. My positional encodings, I wrote my own, which is also an embedding. Don't judge me. You don't judge me. We did this back in ChatGPT 2. So this is a GPT-2 approach to use positional encoding with an embedding, because it means that it learns the positions through embedding. And then we've got an output projection. We've got our own tokenizer that we wrote from scratch. We've got a max context size. Our optimizers at MW, don't know if that matters. Then our block. So here's our transformer block, which is where the real beef comes in here. So standard QKV. We didn't merge the projection, so that's something that we could do to increase the performance. We can merge these projections into one linear projection, so that way it's a little bit faster. And then we have an attention projection, which is just, a linear throughput. You don't need to worry about that. That's just the output, so that way you can run it through again in multiple blocks, in a block loop. We have 3 norms, and then we have a linear layer for the feed forward. So this is mostly some of the feed forward right here. Feed forward is just some dense layers with, oh, you know what? We forgot to turn off the dropout. Oh, well, it doesn't matter. Doesn't matter. All good. Embedding for positions. Yeah, that's me. Yeah, no, you can do it. You can. Yep, absolutely. And it works. It works pretty well. Residual connection. I don't know what that is. What do you mean residual connection? I've heard the term before, but if you could help me, I'd very much appreciate. I'm going to Google it at the same time. Google residual connection in a, a transformer model. I don't know what this is. ASCII. Hey, ASCII. How are you so knowledgeable? Have you worked on some AI before? Yes, I've been doing this since 2014. I've been working in AI before the frameworks even came out, so I had to write all of it from scratch. The transformer didn't exist back then, and CNNs were barely on the scene. Search it. It's going to improve the learning. Okay. Residual connections, or skip connections, act as information highways in the transformer model by adding layers input directly into the output. Oh, yes, I am doing that. They solve the vanishing gradient problem, preventing representation collapse, allowing the model. Does this count here? So where's my input? Let me go attention. I remember writing this. We wrote this right around here. So FN attention right here. Okay. Where is it? It's around here somewhere. Was it in my attention? No. Where's my norm at? Norm. Yes. Here we go. That's the definition. Here we go. Okay. Right here. This line right here. Does that count? Sumit? Does that count right there? I think it might. Residual connections as we mask a certain input that holds value and then add it to the output at the end. Yeah, man. All right. So good to me. Thank you. Rust, there you go, Kyle. Thank you, guys. So good to have you here. Okay, so the plan for tomorrow is everyone has been regularly asking to build a retrieval augmented generation application and to do it in a way that uses vector embeddings, but we want to go beyond that. We don't want to just use vector embeddings. We want to use indexing and full text search. So we can achieve slices of data in context that match the similarity of the user's prompt. So we can pull those pieces of information in to augment the AI's response. So that's the plan for starting tomorrow. So we'll be back tomorrow, you guys. We're back tomorrow, and we're going to be doing retrieval augmented generation a lot easier because now we're doing just application development. We're not doing much AI science here. This is just app development. We'll be using TurboVec, SQLite for an embedded database, and the full text search. And then we will do some data splitting. And then we will throw a prompt in, and then the output will be some text, including the citations maybe. And then potentially, we will also add a model in. There we go. Uday, hey, Righteousness. Oh, thank you for subscribing. You're going to have a good next couple of days as well coming up here. We're going to be building that RAG system that we're just talking about. Good to have you here. Just sent you a connection request on LinkedIn. Sounds good. Thank you. Quick question. How large was the data set for the training? It was almost 1 million tokens. Almost 1 million tokens. So, I mean, not a lot, but it was just me talking. So you see all the words on the screen? All the words on the screen? Just me talking, you guys. Just me talking. Let me render this really quick. There we go. Okay. Here we go. This is it right here. We're going to say it. We're going to say these words before we wrap up stream here because we got to get going. We got a lot of work ahead of me. I have regular work, you guys. I've got to do some work. I'll check your connection on LinkedIn when we're done with stream here. All right. So the Stephen Hay at tomorrow, all now, dot depends. Top option. All right, Rust. I was saying the words, but it's not perfect. We need to train it a little bit more, right? We got to train it a little bit more. Features do okay. Android, Rust, everything. All right. This is it, you guys. You see, okay, look, right? The account screen says, let work right. Okay, grab what? Well, that last one didn't work out very well. But you know what? If we trained it for long enough, overnight, I'm pretty sure it'll be very good. I'm pretty sure. All right. Uday Righteousness, again, thank you for subscribing. I'm glad to be here. Can you help with a guide on how to learn machine learning through? I started my learning process. Nice, already. I'm good with Python. Nice. Okay, so you're going to want, scikit-learn to do standard ML. This is not deep learning. This is standard learning. Then I recommend like Keras and TensorFlow. It's an easier getting started. You could also skip that and go harder mode. Use PyTorch or JAX with Google JAX, which is Google's answer to PyTorch, right? So those are good options. Those are great options, you guys. Context messed up in the end a little bit. Yeah, it did because we didn't fully train it, right? We're only training on a little bit. So we got to train it more. The good news is it's actually getting us some output. One of the things that's going to tell you if the model's really broken is if it repeats a whole bunch of the same word over and over and over. That's when you know it's broken for sure. Righteousness, you're welcome. All the best, man. Thank you, guys. All right, we're going to wrap up now. I'll answer all the rest of your chats, any chats that you guys have left, and then we're going to wrap up here, and we'll be back tomorrow with starting our new RAG, our retrieval augmented generation, because you guys asked for it. We'll do Axum and Rust, SQLite, and we will do TurboVec, which is also Rust. TurboVec, all Rust. So everything native Rust. All right. It is true that nobody knows how these transformers, neural networks, or whatever makes the calculations and output values. I heard something along these lines. Maybe you can clarify. So we kind of understand it mostly, right? It's just a bunch of if statements, basically. It's like basically having a bunch of Boolean operators. And the more Boolean operators you have, the more decisions you can make. And so it makes a bunch of micro decisions. That's the way I see it. Now, when it comes to fully understanding what the model's actually going to be doing, it's hard to predict because it's statistics and there's too many variables. So from that perspective, yes, we have no idea what it's going to do. The good news is you can run it through a bunch of heuristics and testing, and you can see a general performance. So we kind of have enough information to know enough that we understand what's going on. Fun stream today. Goodbye, everyone. Sergio, yep. All right, you guys. Enjoyed having you here. We'll be back tomorrow. More retrieval augmented generation, and more Rust, more AI. That's the plan. All right. Have a good rest of your week, you guys. See you tomorrow. Bye, everybody. Have a good one.